In this video, we're going to wrap up our exploration of solution methods for first-order linear differential equations, which is discussed in the text in section 1.2. Hopefully you watched the previous video in this series. At the end of that video, I asked you to try example 2 on your own. And the first thing we're going to do here is go through a detailed solution of example 2. Example 2 is a little more complicated because the given equation is not given in first order linear form, so we have to put it in that form before we do anything else. Then the integrating factor will be a little more complicated. Other than that, it's pretty much the same procedure that we've been doing in terms of solving our first order linear differential equation. So the initial value problem that I gave you is in the upper right. That differential equation and that initial condition. And it's easy to put that equation in first order linear form just by dividing through everywhere by x. We will assume here that x is positive, since we can see we have a positive value of x in our initial condition. This whole problem is going to break down if x is equal to 0. So we're only going to be dealing with x either always positive or always negative here. In this case, we'll assume x is positive because that's the kind of initial condition that we have. So after we put it in first order linear form, we can identify p of x, the coefficient of y, and q of x is just whatever's left on the right hand side. So we can go ahead and calculate our integrating factor now. By doing that integration, we get the natural log as usual. We don't need the absolute value here because we're assuming x is positive. And we used a property of natural logs here, and then another property of natural logs here to simplify our integrating factor. So our integrating factor is x squared in this problem. You always want to simplify your integrating factor as much as possible in a problem like this before you go on. You wouldn't want to leave it in the original form. Then we take our integrating factor in step 2 and multiply both sides of our differential equation. Now remember, we're not working with our original differential equation, but this differential equation. Multiply both sides of that equation by our integrating factor x squared. That gives us this equation. And if we did everything correctly, we should have the derivative of a product on the left-hand side. You always want to check that and make sure that it is. If that doesn't happen, then that tells you you did something wrong earlier in the problem. So we seem to be okay here, so we can go ahead then, just as we've been doing in the other examples, integrate both sides. The integral of the derivative of a product is just that product. We have an easy integral on the right hand side. Don't forget your plus c at this step because we're almost done. And then finally in step 4, I just solved that for y. So that would be my general solution. In this problem, I did give you an initial condition, so now we take our initial condition and plug in the value x equals 1 into our solution and solve for c. And c turns out to be 15/2, it looks like. Then we take that value of c, plug it back into our general solution, and we have our solution of the initial value problem. Example 3 is similar at the bottom of the page. I highly recommend you pause the video at this point and try example 3 on your own. And after you've tried it, go ahead on and you can check your work by watching the rest of the video. Hopefully at this point people have tried example 3 on their own. You're going to get a lot more out of these videos if you will try things on your own when I ask you to try them, and just do as much as you can. If you need help, of course, help is available either by watching the rest of the video or getting help from me or your classmates. So here's the given differential equation, and we'll deal with this initial condition later. Again, the given differential equation is not in first order linear form, but it's easy to put it in that form, which is what we've done here. Calculate our integrating factor. Just kind of like the previous example, use properties of exponents and logarithms. So our integrating factor turns out to be x to the minus 2. And remember, we're working with this equation, not the original equation. So take our integrating factor and multiply both sides by the integrating factor x to the minus 2. If we did everything correctly, we should have the derivative of a product on the left-hand side. Make sure you always check that. Looks like we're okay here. And I hopefully multiplied x cubed by x to the minus 2 on the right-hand side to get x. So I think we're okay here. I haven't actually recently checked this problem in Mathematica, so hopefully I haven't made any huge mistakes so far. If you find any, let me know. So the left-hand side is the derivative of a product. So we integrate both sides, and the integral of the derivative of the product is that product. The right-hand side integral is an easy integral. Then we solve this equation for y in step 4, and that gives us our general solution in explicit form. Then we recall our initial condition up here at the top of the page and plugging that initial condition in, plugging in 1 for x and 5 for y, we see that the value of c would be 9/2. So we get that thing it looks like for the solution of our initial value problem. That function satisfies the differential equation and the initial condition.